Welcome to Quant Platform Backtest for Finance 372. This is the video when we finally put all the pieces together and run a backtest for our book-to-market strategy. This notebook, which is called Backtest, is the one that pulls everything together, runs all of the other notebooks, creates all of the instances of the classes, and then does the main loop we have written here that goes through the different dates and time to do the backtest. We'll start with our imports here. The only things that are a little different here is we want to import some stuff from ipython.display. This is just going to help us with presentation of the backtest and showing sort of a live update as we go. We're also going to get this copy file utility so we can copy files when we need to. Okay, our first job is to run the 4 complementary notebooks, which we've already written. Each of these other notebooks has class definitions that we're going to need to use. So we're going to run those using this %run command. Once we've done this, we can then create instances of the classes inside these files. Okay, so if you're modifying this backtest code to use for a different backtest, you should change these notebooks to be the names of the notebooks for your custom data processor and trading rule. Next, we create our data processor. If you're going to use a different data processor, let's say we're going to use a Travis data processor, we put that here, but we still call it data processor. We keep the name the same because we're going to use this name going forward. And the cool thing about this code is it's written so I don't need to care necessarily whether this data processor is a Travis data processor or a book-to-market data processor or any other data processor. We create a portfolio database. Then we create a trading rule for the book-to-market ratio strategy, passing along the portfolio database. Again, you would change this here to be the Travis trading rule or whatever other trading rule you'd want to use. Just be sure you don't change the name trading rule here. Okay, then we can create our backtest executor, again passing in the portfolio database. Okay, now we're going to create this strategy info dictionary. And this is where we're going to manually type in a lot of information about the backtest we're doing. We're going to then save this information into our output so we remember exactly what we were doing. In this case, we're going to do a book-to-market strategy based on deciles with equal weighting. So we'll use a brief descriptor that matches that. This is the plot descriptor that goes on our plots. We'll call this a value. We'll label it very carefully as the value book-to-market strategy with equal weighting. Our universe will be public U.S. equities with accounting data. The signals will be book-to-market ratio measured at the most recent earnings announcement. Trading rule specified here, holding period. This whole periods per year, this has to be a number because remember we're going to use that inside of our statistician. Time lag, I'm going to say it's the number of days since the most recent quarterly earnings announcement. And I'm actually going to grab this directly from the data processor. So if I change this number inside the data processor, my strategy info will update that as well. Okay, and then I'm going to just use as a folder name for our output. So that's where it's going to put it in this folder here. Now we're going to create our backtest statistician. And you can see I made a little change to this since the last video, where inside the constructor for the backtest statistician, and you can see I've made a little change to this since the last video, where inside the constructor for the backtest statistician now, I'm passing along this strategy info. And then inside the strategy info, I now have the name of the output folder. And so I can make this backtest path right away. So I can create one of these subfolders in here right away when we construct the backtest statistician. The reason I wanted to do this right away in the constructor is that now what we're going to do, just for record keeping, is copy in all of the Python notebooks we're using to run this strategy right away. This way, we'll have inside of our output folder the exact pieces of code that were used to create the output. This will allow us to go back if we need to and recreate these results because we have the original code in here. Okay, and then the last thing I'll do is I'll create a strategy info CSV file that contains all of this info we're using here. All right, so let's run this initial cell here. Now we can have a look at what goes into this subfolder here. So we've created this subfolder for our backtest. This is the current date and time. Inside here we have all of the Python notebooks that we use to run this backtest. And we have a strategy info CSV, which contains the descriptor, everything that we just set. All right, now we're ready to run the actual backtest. What we're going to do is we're going to initialize the portfolio to have $100 cash. And we're going to get our unique dates from the data processor. And then we're just going to follow the pseudocode we have here, where for each unique date in the data, we're going to do each of these 5 steps. To see how that works in code, we're going to first get our signal and price data frames from the data processor. We'll update the prices because this is a new date, so the prices in our portfolio for the old securities need to be updated. We need to reflect those returns that have happened. All right, and the reason we need to do this right away is because sometimes the current prices may affect our trading rule. Okay, now we ask the trading rule. What do we trade? We give it the signal data frame, and the trading rule is going to give back to us which trades to open and which trades to close. Those close and open trades data frames are going to need to know what the date is. Okay, now we'll go right ahead and use the trade executor to execute the trades, passing the open trades data frame and current prices, closed trades data frame, current prices. Remember, these executors will themselves call the portfolio database and tell them to update as well. So these trades will be reflected in the trades database right away when we do this here. Okay, so the last thing we need to do on this date is to record the account data, write down what our current NAV is, and current margin requirements and current cash. The record account data function does that for us. The last chunk of code here does some nice fancy output where it shows each day a current NAV and the current margin requirement for the backtest. Finally, once this whole thing's done, we'll tell the statistician to output some statistics. All right, so let's run this thing and see how it looks. You can see that it's showing us for each day in the backtest the current NAV and the current maintenance margin as it evolves over time. This just gives us a sense of how much progress we're making. Of course, all of this will be output eventually at the end by the statistician. Fast forward a few minutes and this thing finishes. At the end of 2019 in this case, you can see here the plot of cumulative NAV, but the real juice here is in the output folder. We go to this output folder, we go to the subfolder for our specific backtest, and you have everything we created before. We have the plot of the NAV here, but you can also get the backtest stats here, and if you want the full account history, it's here, etc., etc. Jumping back to our backtest notebook here, everything in this cell, the main loop of our backtest, is pretty standard and should not really change across any different kind of strategy you're going to do. The main things that will change are the specific data processor you use, which we set up here, the specific trading rule we use. Maybe we'll want to mess with a backtest executor and change it to do something with liquidity. Maybe we want to change your output. Well, we'll use the backtest statistician then. Okay, the only thing you really want to change and be very sure is right every single time is this part here. Make sure you're explaining well what the strategy info is. Every time you do a backtest, you should change something about this because presumably you're changing something to make this thing run again. Okay, and this will let you keep track. If you go back to your output folder, if you now have 20 folders in here, you'll be able to look one by one and look into strategy info and see, okay, yeah, that's the one time I did this specific thing. The nice thing about the way this is set up is I can add something else to this strategy info, like, note to self, I fixed bug X this time, exclamation point. Okay? And this will not have any effect in the actual procedure of the backtest. It will only just be a note that appears inside of this backtest info CSV. You'll just have another note to yourself right here. Okay, and that's it. That's how the Quant platform works. Hopefully these videos have given you enough of an understanding of how the code works to build on it, extend it, modify it, and test any different quantitative strategy you can dream of.